All right, so up at the top, it says, in any triangle ABC with sides A, B, and C units in length, and that's the same exact triangle we've been looking at. Side A is across from angle A, side B is across from angle B, side C is across from angle C. So in any triangle ABC with sides A, B, C, units in length and opposite angles A, B, C, and C respectively, sine A over side A is equal to the sine of B over side B, which is equal to the sine of angle C over side C. Or we can flip those and have A over the sine of angle A is equal to B over the sine of angle B, which is equal to C over the sine of angle C. And the proof of that is really easy. If we take that area of a triangle formula that we talked about on Friday, which is 1/2 BC sine A is equal to 1/2 AC sine B, which is equal to 1/2 AB sine C. And we divide each one of those by 1/2 ABC. The 1/2 and the BC's cancel out, so we end up with the sine of A over A equals the sine of B over B equals the sine of C over C. And we use this whenever we're given two angles and one side, or when we're given two sides and the non-included angle. Remember, we use the law of cosines if the angle is included between your two sides. But when the angle is not an included angle, then we're going to use the sine rule. So two angles of a triangle are known. Then we can always find the third angle, as the three angles must add up to 180. So if we know two of the angles, we can always find the third one. So if we have two angles and one side, the sine rule can be used to determine the lengths of the other sides. So here is find the length of BC correct to 3 sig figs. So by the cosine rule, no. Okay, so if we look at this, we have BC here is A centimeters long because it's the side opposite little a, or angle A. So using the sine rule, we have A over the sine of 47 degrees is equal to B over the sine of angle B, which B is going to be 5.6, over the sine of angle B, which is 29 degrees. So sine of 29 degrees. And then we solve this by cross multiplying and dividing. So when we cross multiply, we get A times the sine of 29 degrees is equal to 5.6 times the sine of 47 degrees. And all I've done there is cross multiply. And then I divide both sides by the sine of 29 degrees to get A. These cancel, and I'm left with A is equal to 5.6 times the sine of 47 degrees divided by the sine of 29 degrees. And when we plug that into our calculator, we get A is approximately 8.45 centimeters. So that is how we can use the sine rule to find a missing side if we're given two angles and one side. The other thing we can use this for is if we have two sides and a non-included angle. So here we have two sides, but notice our angle, we don't have the one that's included in the middle. We have a non-included angle. We can use the sine rule to determine the other angles. So the way we would do that is we're going to let ACB, angle ACB, be equal to X. So we're going to let this equal X. Or angle C, either one. So we're going to have sine of X over 15 is equal to the sine of 37 over 20. So we're using our angles and then our sides opposite, and we're setting up our ratio. And again, all we do is cross multiply. So we get 20 times the sine of X is equal to 15 times the sine of 37. We're going to divide both sides by 20. So then we get x is equal to, and I'm going to move up here. Actually, we get the sine of x is equal to, let me erase that. Sine of x is equal to 15 sine 37 divided by 20. And to find x, we take the second sine. So we're going to take the arc sine of 15 sine 37 over 20. Plug that into our calculator, and we get approximately 26.8, and that is in degrees. So angle C, or x, is approximately 26.8 degrees.